Good morning, everybody, and welcome back to Next Door NetAdmin. This is part 2 of the tech validation scenario that I started last week, which was needing to build a system with three-way mirroring and test it all out to make sure that it works. If you haven't seen the other one, I would encourage you to watch at least like the first 5-10 minutes of it so that you have a general overview of what the requirements are that I'm trying to meet and some of my thoughts on how to do that. I've done some more research because at the end of that one, I went, I need to do a little more research to figure out how this is all working. And I've done that. So here's what we're actually looking at. If you remember from there, I was looking at it and there were 4 partitions there. And the partitions were an EFI boot partition, and then there were 3 Linux file system partitions, and I've figured out what each of them actually are. Those partitions are the EFI boot partition. This is typically a FAT32 system, and the reason for that is because UEFI is only required to implement support for FAT32. Some EFI implementers might include boot support for other file systems, but it's not required. So FAT32 is the only one that everything is guaranteed to support, and so an EFI boot partition will usually have a FAT32 file system. Then you have a ZFS boot pool, specifically where it's keeping the ZFS, it's a ZFS file system where it's keeping all of the boot files, all the additional kernel versions, initial RAM disks, etc. The third partition is a swap partition, and that is just straight LUX. There's nothing else on there. And because it's set up as swap, it actually clears every single time you boot the computer with a completely random encryption key every time. And that's fine. That's completely acceptable. Then you have the ZFS root pool. The ZFS root pool is encrypted, so the system is encrypted, and it's using ZFS native encryption. But I wasn't entirely sure at first what the whole thing was with it being LUX and ZFS and how those interacted. But I have started to figure it out. And I've certainly figured it out enough for my purposes. In this case, ZFS is set up to use a key file as the key that it uses to initialize encryption for ZFS native. But ZFS really doesn't have a lot of flexibility for how it unlocks that. However, LUX has a lot of flexibility in how it unlocks itself. So in order to, set up a system where you can add additional forms of authentication, such as a TPM or a FIDO2 key or other stuff like that, what Ubuntu has actually done in this case is the key file for ZFS encryption is on a ZFS pool, which is why Grub loads a module for ZFS, but the ZFS dataset or ZVol where the key file is located is actually LUX encrypted, not ZFS encrypted. And then when you're booting, which I did, and it doesn't seem to be doing a heck of a lot right now, so that's fabulous. Let's just reset that. When it boots, and as you will see here in a moment, it prompts for the password. That's actually a LUX prompt. And what you're trying to unlock is the key store for the root pool. And when you do that, it unlocks the key store for the root pool, and then the key file is available so that ZFS can decrypt and mount the root pool successfully. So it's a bit of a two-stage process. We're not using ZFS on Lux, and in this case, we're kind of using Lux on ZFS, but just for that particular key file. The rest of it is fine. So, great. And let's make sure I type that in correctly, otherwise it's not going to work very well. There we go. Lovely. So, now that we're booted into this installation and we know kind of what we've got here, and I realize it's a little convoluted, but I've also done my research on more specifically what I want to do in order to get from where we are right now to where we want to be, or at least where I want to be. So let's just, that's wrong. All right, so if I do my list of disk partitions, cool. We can see that SDA has 4 partitions: EFI system, Linux, Linux, Linux. Great. We know what these partitions are now. This is our FAT32 ESP, EFI system partition, a boot pool for ZFS, a swap device for, it's just Lux encrypted, a swap device for the system, and then the ZFS root pool. Okay. But we can see that SDB and SDC are not partitioned at all right now. So the first thing that we're going to need to do is copy the partition table from SDA, disk 0, to disks 1 and 2. I've concatenated some of, I've not concatenated. I have gotten some of these commands from useful sources around the web, like Stack Exchange or man pages for the various manuals. I have not had to figure all of this out on my own, but this is kind of what these commands are doing. This is going to dump, that's what the -d is, it's going to dump the partition table from whatever our source device is, and it's going to dump it to a file called part table. Okay. sfdisk will quite happily write an exact copy of the partition table to the new disks, but we don't actually want that because it will keep the same label ID as the original drive, and then to the system it'll look like we've got drives with the same label, and it'll keep the partition UUIDs exactly the same. That's great if you're trying to do an exact copy, but I want to actually be able to distinguish the partition IDs. And part of the reason why I want to do that, if we take a look at our crypt tab, just for funsies here, you can see that we're referencing this based on the partition UUID. And so if I have multiple partitions with the same UUID, suddenly I'm going to have a lot of difficulty referencing them. Why do I not want to just use the partition, raw device files like SDA1, SDA2, etc.? Part of that is simply because you're not guaranteed to always enumerate your disks in the same order. In a virtual environment, you might be. But in a hardware environment, maybe not. And if you remove hardware and replace it, move things around, the partition UUIDs should stay the same because that's on disk. But SDA versus SDB versus SDC depends on enumeration order, and that's not necessarily guaranteed to always be the same. So using UUIDs for reference is more reliable long-term than just going with the short version. And so that's what we're doing here. So this grep command will basically read all of the lines in the partition table but omit the label ID line. Then we're going to use stream editor to take out a comma and then a UUID. And then we're going to use sfdisk to dump that partition table directly to the next SCSI device that we need to have. And sfdisk will regenerate a new label ID and a new UUID if those are not included in the table that it's dumping to disk. So this basically strips out the stuff we want to be specific to the other drive, and we're going to allow sfdisk to regenerate that. Let's give this a try so that we can actually see what it looks like. And for whatever reason, my copy and paste is not working. It's not working happily today between Notepad and Hyper-V, so I'm going to have to type these in. So editing, here we go. Okay, so there's our command sfdisk dump from SDA to partition table. Great, let's do that. Done. Now, if I take a look at the partition table, like I said, it's got a GPT disk. Yes, it's got a label ID. That's something that's specific to the disk that I want to remove. And then it's got SDA, it's got all the partition IDs here. Sizes, that's fine. Type, that's fine too. The type is actually kind of important for the EFI system partition because that's how it knows it's an EFI system partition. And all the rest are Linux file systems. Great. But then these UUIDs, the partition UUIDs, that's what we want to regenerate. And so we're going to move to our second command to actually take this particular table and write that to the other disks. So give me another second and I'll have that typed in for you. All right, here we are. We've got our line to grep the part table, omitting label ID, and then we're going to stream edit to just remove this trailing comma and then the UUID line, and then we're going to dump that into sfdisk and write that to SDB like so. And you can see that it's checking that no one's using the disk. Yeah, that's right. Okay. And then it created a new GPT disk label with a new GUID. We're not using this label ID for the disk. We're just going to create a new one. Creating new partitions. And there we are. All done. Cool. So I can now do the same thing with SDC. And we're going to do exactly the same thing, but we're going to get a new GPT disk label from what we had for SDB as well. Cool. So all of that has been done. And now if I do fdisk-l to just list that, there we go. We can see that we have an identical partition table on all three of these disks. Perfect. That's the partitions. Now what do we do with them? Well, we need to create additional EFI boot partitions. In this case, part of what we need to do is just create a FAT32 file system on the other two, which they're always the first partition. This is going to be SDB1 and SDC1, but that's pretty simple. So let's just move that down a little bit here. Make this VFAT, virtual FAT. I want to specify that this is FAT32, and I'm going to put it on not dev, there we go, SDB1, there it goes, and SDC1, done. Okay. Now, how about this line, dpackage reconfigure? Well, as it turns out, Grub actually has the ability to keep multiple ESP partitions, EFI system partitions, no redundant acronyms needed here. Grub can keep them all in sync. If you tell it that you want to use all of these boot partitions. And then if we lose the first disk, there will still be bootloaders on disks 1 and 2 that will take over from disk 0. So if we tell Grub to use all of them, it will actually keep them all in sync. And something else that's kind of cool, one of them is currently mounted at /boot/EFI, but the other two don't actually have to be mounted at all. Grub will take care of it. Demonstration, here we go. Dpackage reconfigure, there we go. Grub EFI AMD 64. Okay, so the first thing you'll say, Do you want to update the command line? No, that's fine. Do we want to update that as parameters? No. Are we going to use OS Prober? No, we're just using Linux here. Am I going to update the NVRAM variables? Yes, because if we take a look at settings right now under boot from file, the firmware in Hyper-V is currently set to boot from shim x64, which is fine, but this is on the first hard drive only. And we want to make sure that we get the other hard drives in there as well. So, are we going to update NVRAM variables? Yes, absolutely we are. And now it wants to know which of these EFI system partitions are you going to use? And we can select all of them. One is currently mounted on boot EFI, but the others are not. And that's, again, perfectly okay. When we do that, cool. Grub just went through and took care of it all. It installed Grub to the currently mounted one, boot EFI, great. But then it mounted one to var lib grub esp, installed Grub there, unmounted it, and then mounted the second one to the same location, installed it again, and we're done. Cool. So then it added a boot menu entry for UEFI firmware settings. If I go and take a look at my settings again in Hyper-V, firmware, now we've got 3 copies of shim x64 available to be booted. And if one of these is no longer present, the others can kick in and continue booting the system. And given that it will be a 3-way ZFS mirror, it will be able to actually mount the ZFS pools from the surviving disks and will still be good to go. Cool. So that is another step in the right direction. What's next? Before I get to the ZFS pools, I'm going to add additional crypt tab entries for the additional swap partitions, because I have a swap partition on the first disk, but I also have swap partitions on the other disks. And since it's swap, they don't really need to be kept in sync. They're going to just be used separately. And that's, again, perfectly okay. If I go and take a look at my, you know what, let's add a couple lines of blank space there just to make this easier to see. If I take a look at my crypt tab again, I can see that this is just dmcrypt-0. That's the name of the device. And then a partition UUID. The key file in this case is dev-urandom. It's just a random string every time. And it's labeled with the options for swap, which causes it to be cleared every time it's reloaded, and initramps, which means that this is a partition that we need to include the tools and scripts to unlock in our initial RAM file system. That's a system image type thing, and I don't know, strictly speaking, if I need to include this specifically. If I've already got the scripts and tools for one, it should be the same tools for the others. But I'm going to add that anyway, mostly for the sake of completeness. But I'm also going to need partition UUIDs to do this. So how do I get that? Well, move that down a little bit more and say block ID. There we go. That's what we wanted to see. And we've got partition UUIDs here. Now, I know that the first one is SDA3. That is our first loop block, and it has a UUID here. But this UUID is the UUID of the decrypted dmcrypt0, EE777. That doesn't match what we're seeing here in crypt tab. This is the partition UUID of the host partition, 590A, etc. And so if I look through here for SDA3, you know what? SDA3. There we go. SDA3 is 590A, etc., which is exactly what, oh, it was at the very bottom. Look at that. Nah, found it. See, even a experienced system administrator sometimes just has a blank moment where you can't see what's under your very own nose. All right, so I'm going to want SDB3, which is this part UUID. And in fact, I'm just going to copy this entire line. There we go. And then when I nano etc crypt tab, okay, I'm basically going to replicate this dmcrypt1, and I can copy, or excuse me, paste my partition UUID in there, and I can take away the quote marks because those aren't needed. Dev urandom swap init ramps. Okay, cool. Let's save that, and we will get SDC3, which is this guy. Very important here to be sure that you are copying the correct partition IDs. SDB3 was CB5. Yeah, okay. Init ramps. There we go. All right. So now crypt tab has all of that available to it. Let's pause for a moment here and reboot the system to make sure that device mapper, which is the DM in this case, can actually get those initialized. Yeah, restart. Off we go. Let's ls dev mapper. Okay, so the device mapper DM has successfully created dmcrypt0, dmcrypt1, and dmcrypt2, as well as our key store rpool that is the Lux unlocked volume in the ZFS pool, in the ZFS in the ZFS pool that has the key for the remainder of the ZFS native encryption. Okay, so those are working fine. So we've added the crypt tab entries for the additional swap partitions. Now I want to modify my file system table entries to get those additional swap partitions in there. And here's another important part. I need to mark all of the swap partitions and the EFI system partitions with no fail. Because if they fail to mount because a disk is gone, then the system will start to freak out. And I don't want it to freak out. I want it to be able to continue boot even with a failed disk. So let's modify our system partition table here. Etc feast tab. There we go. All right. So this is the line that basically I want to copy. Now this is dmcrypt1 and dmcrypt2. But then I also, you know what? Stop highlighting that. Thank you. Swap is the option. File system, oh no, excuse me. Swap is the type. Options is SW. I'm also going to add no fail there so that the system knows it's okay if it's missing one of them. Okay. And then I also want to make sure that this also has no fail on it, because that's our boot partition. /boot/EFI. Because remember, grub still works fine with the other boot partitions, the EFI system partitions. It was able to mount those and update those without them having to be mounted on the file system. If my first disk fails, then yeah, obviously /boot/EFI will not be available, but the system will still have booted. And so I wanted to make sure that it doesn't fail the boot just because it doesn't happen to have that first disk available. So let's do that. And I'm also going to make sure dev disk by ID. Okay. So let's save that. And I also want to list dev disk by ID. There we go. Because I want to see that we have, yes, DMUUID crypt plane, DM crypt 0, 1, and 2. Those are the devices that we just put into the file system table. So we're good. All right. And now, the fun part, attaching additional devices to the ZFS pools for mirroring. First thing I want to look at is my zpool status. Actually, the first thing I'll do, just for, sake of argument here, is zpool list. We see we have B pool and R pool, the boot pool and the root pool. Okay, cool. So then if I do zpool status for B pool, all right. So currently we have the boot pool, and it has one device, this WWN something 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 part 2. Okay. If I go back and do my list of dev disk by ID again, but this time I add LAH, which in this case L is long, which gives you details including permissions and read, write, execute permissions and ownership information, but also shows you what the symbolic link leads to. Very, very useful to have, because we can see that WWN 0x600 22 etc., with a deb in there as opposed to nothing particular or an EED. I'm just looking at substrings that make them stand out to me. But this deb one is SDA. And so part 2 is SDA2. When we scroll up and look at it, we can see that this is indeed deb part 2. This is SDA2 that is currently in the boot pool. Okay. So I want to add another one of these second partitions, like this one, which is SDB2. See that there. So if I copy that, let's not copy that yet, because our first command is zpool attach. The pool name, we need an existing device and then a new device. So if I do zpool attach in the boot pool, and then I want this one, whoops, let's get the whole thing. There we go, part 2. All right, there we go. And then I want to add SDB2, which is this one. Copy and paste again. There we go. That is our command. Zpool attach the boot pool, the existing device, and then a new device. And when I run that, now if I do the status on the boot pool, suddenly it's now a mirror. It's now a two-way mirror. And we can see that it resilvered 106 megabytes. Done. Just like that. Okay. So these two are now mirrored. And we can do exactly the same thing if I, say the original device, all right, it's DEB, it's deb, fine. But now we copy SDC2. And again, we're not using SDC2 because SDC is enumeration dependent. We're using the worldwide numbering for this to indicate the actual partition ID. Fine. And then if I attach that one and do my zpool status for bpool again, it's now three-way mirroring all under the same mirror. And I've established a three-way mirror in ZFS after the system was installed. Okay, cool. And it resilvered again. The timestamp is different, 01 versus 55, so it's done two resilvering operations to make sure that everything is up to date. Okay. Now if I do the same thing with the root pool, Okay, this is using a SCSI definition instead of a worldwide name. They're the same thing, essentially. These ones are worldwide names. They're symbolic links to the actual hardware devices as enumerated, and the SCSI devices go to the same thing. So this is really just going to be a matter of, yeah, same thing. It's DEB, EED, etc. It's just an alternate way of referring to it. So in this case, I'm going to mirror partition 4. This one has more data in it, so resilvering, we would expect it to take a little longer, but there we go. It's created a mirror instead of a single device, and the resilver is now in progress. And it's scanning the data on the root pool to determine what it needs to replicate, and then it will do that. Cool. One or more devices is currently being resilvered. Great. If I run it again, it's already 2 gigs done. All right, cool. While it's doing that, and it shows you which device is currently resilvering, we can go ahead and add the third device as well. And then when I do that, all right. So the first one has completed. It's no longer resilvering to SDB, but SDC is now going to do the resilvering as well. Wonderful. And if I just check that a few more times, yeah, it's continuing to go. That should basically be it at this point. We've made sure that we have multiple boot partitions and Grub is configured to use all of them. We've made sure that we have swap partitions on each disk so that even if we only have a single disk, it still has swap available. We've made sure that they are mounted in the correct location and that the failure of any individual one does not cause the system to consider boot a failure. And now we've added multiple devices into our boot pool and into our root pool so that we have 3 copies that are all being kept in sync by ZFS. So at this point, resilvering is completed, everything is good. I'm ready to begin testing this. So let's exit that. Let's do one more reboot to make sure that it boots correctly with all of the changes that we've made. And then I'm going to start fiddling with disks and seeing if it works with a disk being removed, and we'll be able to validate that the design actually works. So here we go. Let's see what happens. Yeah, okay. So swap on, we have swap that's being used on all of these currently. Cool. Interesting to me that these are /dev/dm dash whatever, but I will bet that if I also do just a check of dev/dm whatever. Okay, these are our device mapper. Okay, sure. And if I do dev mapper, dmcrypt0 actually goes to dm1, and dmcrypt1 goes to dm2. Keystore rpool actually goes to dm0. So yes, this is entirely correct that swap is on dm1, 2, and 3, even though it's dmcrypt 0, 1, and 2. These are why we check these things. Okay, so all 3 swaps are loaded and running. We know that we have zpool status boot pool. Shows everything is online and good. If we do zpool status rpool, that's all good too. Wonderful. Okay. So let's shut down the system and then start messing with it. And this is the part that I have no idea how it will go. So we're both going to discover this pretty much at the same time. I can minimize that because I don't need that in the background anymore. All right, settings. Let's say I want to, I can't edit it because checkpoints exist for the virtual machine. Okay. Well then, I'll get rid of the checkpoint. Give me a second here. Okay, I've removed the checkpoint, so let's check that again. All right, now I can fiddle with it. That's great. Let's just remove the first one entirely. And then I'm going to add, no, I'm not going to add a SCSI controller. I'm going to add a new hard drive. Just there. Apply it. No, I'm not. That doesn't make sense. I wouldn't have a hard drive with no backing media, so let's just remove the hard drive altogether and be done with it. Okay, so we've removed it. We now have 3 shim entries. One of them's not going to be there anymore, but the system should still boot. If I'm right. Let's see if I am. Moment of truth. We've got a grub menu. Wonderful. Now let's see if it actually can get through and boot. Because we've taken away SDA, there we go. Okay, we're waiting for encrypted source device with a partition UUID. Okay. And we didn't have that, but we can unlock our key store RPool, which is good. But we will not have our file system at /boot/EFI. There we go. All right. Took a little longer to come up than I was expecting, but if the only sign of a boot failure is it took a little longer to come up, I'm okay with that. All right, and we've only got 4 devices listed here now. Okay, okay. So it booted successfully. Good. If I do swap on, we've only got 2. All right, that's fine. I don't think I have /boot/EFI, which makes perfect sense. If I ls boot, I have an EFI directory, which makes sense because you need a mount point for that. But EFI is empty because that's where we would have tried to mount our ESP for the other one. And if I do zpool status bpool, all right. Haha, we have a device that is unavailable and the mirror shows degraded, but we still have 2 copies online. So that's good. It was this one that's not there anymore. And the same should be true for our pool. Yeah, exactly the same. Degraded because one device is unavailable, but the other 2 are online and still functioning. Excellent. And then you can actually replace the device. You could just put in a new device, replicate the partition table just like we did already, and then add those new devices using zpool replace to replace the failed device with the new device. But functionally, it's the same process that we've already gone through, and that would be fine. Okay, wonderful. So as a proof of concept, I like it. That worked for me. If I'm curious about, I want to see what we've gotten here. Aha. So here we are. Exactly. These have remapped. So even though we removed the first disk SDA, it has now enumerated this particular WWN as SDA. And it has enumerated this one as SDB. So could we actually have set up our file system table to say dev SDA1 goes to boot EFI? Yes, we probably could have. And now that I'm thinking about it, if I'm doing by ID, DMUUID crypt plane, does it Do though, no, it doesn't. This is still dmcrypt1. This is still, excuse me, dmcrypt1 and dmcrypt2 because those were named by their partition IDs. So dmcrypt0 on disk 0 is gone, but because we don't have this UUID available, boot EFI didn't stick around. But in theory, you could change that to just be dev SDA1, and any of your disks that actually show up as SD anything, if SDA1, or excuse me, if SDA fails and it reboots, then the next disk would become SDA1, and therefore you would always have a /boot/EFI mounted, and it just which one it was would change. So theoretically, yes, you could do that. And I might just for /boot/EFI. But I might not. I don't know. As a proof of concept, though, yes, I was able to remove a disk and the system booted just fine by manually installing. First, by installing the system using the installer, using the ZFS and encryption options. I've got a redundant, resilient file system. Not redundant as installed, but resilient for sure. And I've got full disk encryption. But then I was able to manually add steps to copy the partition table over, create the additional EFI boot partitions, make sure that I have additional entries for swap, make sure that the system doesn't treat the failure of a disk as a failure of boot and throw panic messages all over the place. And I also updated the ZF pools for three-way mirroring. You know what? I'm pretty satisfied with that. As a validation of the design and all the bits of pieces of this should all work, it should all work. And it seems to be working really well. So I say that that is a success. For me, anyway, it's a success. So there you go. This has been a look into what it's like when a network administrator, or a system administrator in this case, goes and has to validate a new design using knowledge that they already have but have never actually had to put into practice before. But there you go. A little glimpse into what it's like. If you have thoughts on the process, if you think I've missed something, or if you think I could have done something better, feel free to let me know. If you have thoughts on other things that you would like to see me demonstrate, or things that you'd like to hear me talk about, feel free to let me know right down there in the comments section. Otherwise, thank you very much for watching. I am your next door NetAdmin, and we will see you next time.